Greetings, everyone. This is Jeff Wilkerson, professor of physics at Luther College, bringing you the next in our series of what to look for in the night sky. It's the week of July 15th. This time around, the moon's filling out as the week goes on, so it starts 70% full. So it's already a lot of moonlight washing things out. But early in the week, the first half of the week, if you want to look for things in the morning, the moon will have set, and you'll be okay to do so. So on the 15th, that 70% full moon will be sitting about 5 degrees south and maybe a little bit east of the star in Libra, Zubenelgenubi. And we've talked about this before. Last week, at the end of last week, the moon did something spectacular. It occulted a very bright star, Spica. Zubenelgenubi is pretty bright. It's not that bright, and it's the star we've seen in the recent years that the moon has occulted more frequently. So the moon passes over it every now and then. It's going to be about 5 degrees south of it as it goes by this time. So that starts to give you a sense. You can think about the geometry of the orbit of the moon. Here's the plane of the orbit of the Earth around the sun, and the orbit of the moon's tilted a little bit that way. And so you get to see how the moon's moving up and down relative to a star like Spica or like Zubenelgenubi. 2 nights later, on the evening of the 17th, so we're talking about the evening here, even though you could follow this through to the morning, 15th, 16th, 17th, 18th. We've got the moon is very close to the really bright star Antares. And Antares is this beautiful orange star in the heart of Scorpius. It'll be about 4 degrees from Antares. The moon's already almost 90% full by the time we get to this evening of the 17th and morning of the 18th. So it's up almost all night. It'll set just a little bit before sunrise, so it's starting to wash out the sky for any kind of observing you're going to do. Antares, great star. It's what we would call a red supergiant star. And so that means it's on the asymptotic giant branch, and it's very massive relative to the sun. 15 times the mass of the sun is what Antares is. And so what we look at is we say most stars like the sun are out there fusing hydrogen into helium in their cores. That's what's going on. And so you've got the hydrogen to helium being fused in the cores of stars in the main sequence. When that runs out, something else has to happen. And the star starts to fuse hydrogen into helium in a shell around that neutral helium core, and it becomes a red giant star. After you've the tracks depend on the mass of the star a little bit once we get up past this red giant phase. But what happens is in a red supergiant, you've got a very massive star where helium has burned into carbon in the core, and then that carbon can be burning into heavier things. You're making an iron core in here, and you're burning heavier elements like layers of an onion. You've got chemical elements being fused into the next heavier chemical element, and that precipitating down into the shell below it, and you're feeding that core. And that's where Antares is. And Antares is pretty far up the asymptotic giant branch. We call this asymptotic giant branch largely because of what it looks like on an HR diagram. If you plot the temperature on this diagram and the brightness of the star, how much energy it's emitting per time up this way, you'll have the main sequence looks like that. And when a high mass star, Antares was a real high mass star up here, leaves, it ascends the giant branch, and then it descends down here on the horizontal branch, we call that. And then it ascends that, so this asymptotic giant branch up here. And it's way up here at the top. That's where Antares is. And so it's very far along in fusing these heavy elements and making this iron core, which means it's about to become a supernova. Okay? And it is a relative thing, but in astronomical terms. So that's something to think about as you're looking at Antares with the moon there. Also, if we look in the morning sky, the Mars, this region rises something like 2 a.m., I think, is what we're talking about. And so Mars is in prograde motion. It's catching up with Jupiter. They're both moving easterly against the background stars. So one way to check this out, go out 3 o'clock in the morning, look at Mars at the beginning of the week. You'll see Mars will be about 5 3/4 degrees southwest of the Pleiades and about 14.5 degrees from Jupiter. So Mars will be glowing red there. You can see the Pleiades. The Pleiades is a nice naked eye star cluster. And so you'll see those two things. You'll see the red dot below the Pleiades, and then look for the bright object, the bright star over this direction, Jupiter. And by the end of the week, Mars will have closed on Jupiter by 3 degrees. So it'll go from 14.5 degrees. They're both moving easterly, but Mars is just moving a lot faster than Jupiter is against the background stars. And so it's closed this down, and it will sit south. Mars will sit south of the Pleiades and just a little bit east. So the distance is about the same, 5 3/4 degrees down to 5 1/4 degrees from the Pleiades. It's what we would call the position angle has changed as Mars has moved relative to the Pleiades this direction. And you'll see that gap close. Draw yourself some sketches. Check it out a few times during the week, and that's going to be a great thing to look at. Now, we've been tracking Saturn. Saturn went into retrograde motion a couple weeks ago, and we started talking about it, and it's closing on this star Phi Aquarii. And if you're really sharp-eyed, if you're really paying attention and making careful sketches of what's going on, you might be able to see that motion back to the west of Saturn relative to Phi Aquarii. It closes that distance by about 1/6 of a degree. Remember, your finger held out at arm's length, that's about a degree. And 1/6 of that is how much Saturn closes on Phi Aquarii. In a telescope, you would probably notice that more. Now, Saturn sits below the great square of Pegasus, this big square that we associate with fall evening sky. But here it is in the morning. So actually, this great square of Pegasus is far enough north of Saturn that for those of us who live, I live about 43 degrees north latitude. And so for those of us who live this far north, this great square rises much, much before Saturn does. And so it's up most of the night by now. So as it gets to be dark, it gets to be 10, 11 o'clock, you can see the great square of Pegasus starting to climb over the horizon. By midnight, it should be pretty well up there. And so we've got this great square. These 4 stars, they're brighter than any of the other stars around, so it just looks like a big square of stars in the eastern sky. Go out at midnight and take a look at that and see Saturn glowing below there. Now, the bottom right corner of the great square of Pegasus, you can track a string of fainter stars across there that turns and goes up that direction. And it ends in a star that's the brightest of any in that chain. And this star is a little bit fainter than the stars of the Great Square, but it's a 2.4 magnitude star. So it's a pretty bright star. Enough is that star. And if you continue that on about the same amount, you come to a really fine globular star cluster, M15, one of the better star clusters in the northern sky. It's not an M13, but it's a really good open globular star cluster, excuse me. And so it's up that direction. So I go about that same distance is what I would do, and look for it with your binoculars or with your telescope that way. And then you take this. So take one side of the great square. That's about how far it is down to there. And then you tip it up a little bit less and move that distance again to get there. You take one side of the great square, tip it down again. So about that distance to that distance. So if you take the distance between these two bright stars, drop south from M15, and you can find M2, another globular star cluster. Summertime's the time to see globular star clusters. We've looked at them a few weeks in a row. We'll stop that here sometime soon. But these are great objects that will hold up to the moon a little bit. But if you're out there in the morning sky, if you're looking at 3 o'clock in the morning, early in the week, the moon will have set for you. And you'll be able to see these globular star clusters pretty well. So if you want some deep sky objects, that's something for you to look for this week. Otherwise, enjoy the moon near the stars and watch the planets move around. And it's a good week for that. So as always, everybody, thanks for watching, and we hope you have a great week ahead.